Okay, we are going to look at dilations now and transformations. First thing we're going to do is we're going to talk about what is a dilation. Okay, remember a dilation is either going to get bigger or smaller. And what should always come to mind when you hear or see the word dilation? Okay, multiply. Whenever you see the word dilation, just know the rule, we are always going to multiply. Okay, we're just going to focus on one letter right now. Okay, let's just focus on G. We have G and G prime. So did that figure get bigger or smaller? Okay, the figure without the prime symbols is smaller than the one with the prime symbols. So this is an enlargement. Okay, and remember, with an enlargement, that means the scale factor is going to be greater than 1. Okay, greater than 1. So we have to find what that scale factor is. So what we're going to do is we're going to find okay, so we're going to use G and G prime. So for G, let's write the ordered pair. Okay, so we're going to go over. So this is 2, 4, 6. And since it's in between 4 and 6, it's going to be 5, comma, and then we go up to 10. Okay, so 5 comma 10. For G prime, we go over here to 2, 4, 6, 8, but it's in between 6 and 8, so this is going to be 7. And then we go up to 14. Okay, remember to find scale factor, it's new over original, new over original. No, no, no. So this is the new, so you can pick either one of those. Well, I'm going to pick 7. So new is 7. Since I'm using the x value, I have to use the first number of the x value here. So 5, 7 over 5. Okay, so this is my scale factor. Remember, with scale factor, you're always going to multiply. So for our rule, it's going to be x comma y. You always multiply by the scale factor. So we have 7 over 5x, comma, 7 over 5y. Okay, let's go ahead and we're going to do another one together. Okay, they want to know which rule best represents the dilation. So remember, it's getting bigger or smaller. So we went from here without the prime symbols to the bigger one. So this is an enlargement. So that tells us the scale factor is going to be greater than 1. So remember, with scale factor, we always multiply. So we're going to start with xy. We are going to find the ordered pair. You can use any of the letters. So let's go ahead. We can use C and C prime. So looking at C, we're going to go over to 2, and then we go down 2. So C is at 2, negative 2. Okay. And looking at C prime, we go over to 5, and then we go down to 5. So 5, negative 5. Okay. This is the original. This is the new. Remember, it's new over original. No, no, no. So I'm going to use the x value. This is the new. So 5 over 2. Well, that is my scale factor. Remember, with scale factor, you always multiply. So I'm going to put 5 over 2x, comma, 5 over 2y. Okay. Now we're going to move to translation. Well, let's go back up here, first of all. Okay, let's talk about if it preserves congruence. Okay, remember, preserve means to keep, congruence means to stay the same size, same shape. So, did this stay the same size and shape? It's the same shape, but it's not the same size. So, this does not preserve congruence. Okay, dilation is the only one that does not preserve congruence. Okay, because it got bigger. Now let's go ahead and look at the translation. Remember, a translation means to slide or to move. Okay, so we move 4 units to the left, 5 units up. So remember, the x goes right or left. This is the x-axis. So here's 0. So if we're going to the left, that means we are going to subtract from x. So 4 units to the left means we are going to subtract 4 from the x. 5 units up, so the axis that goes up or down is the y-axis. Since we're going up, that means we're adding to the y. So y plus 5. Okay, so let's go ahead and match it. We have x minus 4, y plus 5. That matches. We have x plus 4. That's not it. X plus 4, that's not it. We have x minus 4, but if you notice, we have y minus 5. That's not it. So the correct answer is A. Okay, so what I'm going to do is I'm going to pause the video and I want you to do the you do. Okay, let's see if you're right. It says it was translated 5 units to the right, 3 units up. So remember, if you go right or left, that affects the x because that's along the x-axis. So if we're going 5 units to the right, that means we're going to add 5. Then if we're going up, remember this is the y-axis. And if we're going up, that means we're going to add. So that matches letter G. So hopefully that's the one that you picked, letter G. Okay. Now let's talk about this. All we did was move it. Okay. It didn't change size. So therefore it does preserve congruence. Okay, now we're going to talk about a reflection. Guys, I don't know how to get you to understand this. It's just you've got to remember the rules. Okay, so if it reflects across the x-axis, x stays the same. Okay, so if it reflects across the x-axis, the x stays the same, the x value. Okay, and let's just see how that works. So we have V, and here's the x-axis. So it's reflecting across the x-axis. That means it's going to be over here. So if this is 1 down from the x-axis, that means it's going to be 1 up from the x-axis. So if I would fold my paper on this x-axis, my 2 V's would match up, V and V prime. So the ordered pair for V would be 4 down 1, so 4 negative 1. And the ordered pair for V prime would be over 4 up 1. So that would be positive 1. So if you notice, my x has stayed the same, but my y changed to its opposite. So whichever axis you're reflecting across, it's the other one that changes to its opposite. So that rule would be x comma y. It's across the x-axis, so my x stays the same, but my y changes to its opposite. Okay? X-axis, x stays the same, y changes to its opposite. So now what I want you to do is I'm going to pause the video and I want you to do the you do. Okay? Let's see if you're right. A circle is graphed on a coordinate grid and it's reflected across the y. So if it's reflected across the y-axis, that means the y stays the same. Okay? Which ordered pair represents the new circle? So we start with x comma y. It's reflected across the y-axis. So y stays the same. X becomes its opposite. Okay? So let's match that up. No, that one stayed the same. This one, the y changed. This one, the x changed to its opposite. The y stayed the same. This one, they both changed, so it's not this one. So hopefully you picked letter C. Okay, now let's look at rotation. Okay, again, these are rules you have to memorize. So if it's 180 degrees clockwise, that means if this is going clockwise, it's going to end up this way, which is the same if we would go 180 degrees counterclockwise. Okay, so with 180 degrees, what that means is they don't switch positions, they both become its opposite. Okay, so for 180 degrees, doesn't matter, clockwise or counterclockwise, they both become its opposite. Okay, we're actually not going to do this one, so I'm going to cross it out.